Heidi ho, let's get going on example 9. So example 9, you guys, is pretty much the same thing as example 8. So if you want to try example 9 on your own, I say go for it with 2 thumbs up, which is serious. Otherwise, if you feel like you still need to watch the video, that's fine. Just follow along and we'll have a blast. Okay, so don't forget, you guys, I already kind of did the very first step. So we're going to be graphing and stating all the transformations for this lovely equation, and then we'll be finding the domain and range. All right, so remember the very first step whenever we're graphing transformations is to graph the parent function, which remember, these are always the points that I'll be using when I graph the parent function. And remember, all you do is you have to take the square root of the x values that I have in the parent function. So again, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. Alright, so I already have those points and already graphed it. So make sure that you plot those points and graph your parent function. Okay, so remember the next step, whenever I graph transformations, again, it's much easier if you tackle the a value first thing, because otherwise it'll be really complicated to do the a value later on. Alright, so which one of these values is the a value in the equation? That would be the negative 1/2. So I'm going to add on the negative 1/2 to my previous equation. Okay, and remember for the a value, all you do is you copy down the parent function points, which the parent function is y equals the square root of x, but the a value is going to be y equals negative 1/2 times the square root of x. So remember, all you do to get the a value points is to multiply the y values by the a value. So I'm going to multiply every single y by negative 1/2. Okay? And remember, you guys, whenever you multiply by a half, that's the same thing as dividing by 2. So pretty much what we're doing is dividing every single value by negative 2. So 0 divided by negative 2 is 0. 1 divided by negative 2, or 1 times negative 1/2, is negative 1/2. All right, 2 divided by negative 2 is negative 1. And 3 times negative 1/2, well, you can't really divide 3 by 2, so it's just going to be negative 3 divided by 2, or negative 3/2. Okay, now before we plot these points, don't forget, you guys can be math magicians. You already know what's going to happen to your graph before you even graph it, which is pretty cool. Okay, so remember, whenever your a value is negative, and also something other than 1, your graph is going to do not 1, but 2 things. Holy hot dog, right? Okay, so first of all, when the a value is negative, that's when the graph will flip over the x-axis, or reflect over. So I already know the graph will reflect over the x-axis. All right, and then when a is a fraction, or when a is less than 1, which 1/2 definitely is, okay, when a is less than 1, that's when it will vertically compress. So this graph's going to kind of flatten out and get closer to the x-axis because we're going to smush it vertically. Okay, so this graph will vertically compress by a factor of 1/2. So all that means, you guys, is your graph will be half the height that it originally was. Okay? All right, so if we did this right, when we plot these points, my graph should flip upside down and get more narrow, get skinnier. All right, so my points are 0, 0, 1, negative 1/2, 4, negative 1, and 9, negative 3/2, or negative 1/2. Okay. All right, so let's get to plotting these points. So let's see what happens. I'm already excited, you guys. So 1/2, or 1 negative half, 4, 1, 2, 3, 4, negative 1, and 9, negative 3/2, or negative 1/2. Whoa, look at that. It flipped upside down, boom, and then it got more narrow. Look at that. Okay, so then after that, remember, you guys, it does not matter. You can do the H or K first. I personally like to do the H first, but again, It doesn't matter. So if you do the k value first, just know that your next graph will look different than mine. But the important thing is your final equation will be the same graph, which is ultimately what we're trying to graph here. Okay, so what I'm going to do is I'm going to add on the h value to my most recent equation, which is this one. So we have y equals negative 1/2 root x. And then I'm going to add on the h value. Which one of these lovely values is the h value? The negative 1/2, the 2, or the negative 2? Awesome sauce, you guys. It would be the plus 2. Okay, the h value is always whatever is added or subtracted to the x. Okay, and remember, the h value, we think horizontal. Okay, so left or right. But with the h value, you must think the opposite. Think the opposite. Okay, so if it's a plus 2, we're tempted to say right because that's a positive direction, but that's when the demon cats bite your face off. So watch out. Okay, so we're not going to go right 2 spaces. We're going to go left 2 spaces. So be careful. So the graph will move left, or you can write moves left 2 spaces. Okay, so all I'm going to do, I'm going to start with my most recent graph, which my most recent graph is the pink graph. And all I'm going to do is take all my points and count to the left 2 spaces. So just like Beyonce, we're going to go to the left, to the left. All right, so I'm going to start with this point and go to the left, to the left. Then start here. Okay, don't forget, you guys, we are at the half. So when you count over, make sure you remain halfway down. So in between the 0 and -1. Okay, so I'm going to count to the left, to the left. And then to the left, to the up, to the left, to the left. There we go. Around. Actually, that's way off. Sorry, guys. Jeez. Okay. So I'm going to count to the left, to the left. And then to the left, to the left. Okay, so, which I'm already noticing this is like way off. I think it's this one that's off, but basically it's going to look something like that. All right, hopefully your graph looks a lot better than mine. Mine looks a little messed up right now, but that's okay. It'll be all good. Okay, and then lastly, you guys, we're going to be graphing the k value. So I'm going to start from my most recent equation. So it's going to be y equals negative 1/2 times the square root of x plus 2. And I'm going to add on my k value, which the only other value is this -2. Don't forget, you guys, the k value is whatever's added or subtracted onto the very end of this equation after the square root. Okay, and don't forget k, we think kangaroo, which normal kangaroos jump up and down, right? Okay, and the k value, you don't think the opposite. So if we're going -2, we're heading in a negative direction, which is the -2 direction. So this is going to be a negative direction, so we're going to head down 2 spaces. So moves down 2 spaces. Okay, so what I'm going to do, I'm going to start from my most recent graph, which is my lovely orange graph, and I'm going to take all those points and count down 2 spaces. So go down 1, 2. Again, if you have graph paper, this is much easier to do. This one should be at the half. I think that's when the demon cats got me. So that one I kind of put at the 1. It should have been at the half. So make sure when you guys count down, you stay in between your tick marks. So this one should be here. So it's going to go down 1, 2. Okay, so like that. This one's going to go down 1, 2. And this one's going to go down 1, 2. So something like that. Again, it's harder when you don't use graph paper. So I recommend using graph paper. All right, let's see. That one looks a little bit better. It's still a little kind of messed up, but you know, it's all good. Okay, so this is my final graph. Holy hot dog, right? Okay, so make sure, don't forget, the most important step of the whole problem is to name your graph. Your graph deserves a name. So I'm going to name my graph Ashley. Looks like an Ashley. Okay, now when you're finding the domain and range, sometimes it's helpful to draw like a separate graph because if you see like a lot's going on right here. Okay, so this point is at the point 2, -2. So I know my start point is at the point -2, sorry, -2, -2. So -2, -2. And again, I'm just going to approximate it. It doesn't have to be perfect. It looks something like that. Okay, so this is Ashley. She looks beautiful. Okay, So again, there's two ways you can find the domain and range. I'll show you both ways like last time. So the domain, these are the x values, which the x-axis goes to the left and to the right. So you ask yourself, well, how far left does it go? And how far right does it go? Okay, so this is the point -2, -2. So the furthest left it goes on the x-axis is to -2. And then are these numbers over here larger or smaller than -2? Well, there are things like -1, 0, 1, 2. So they are larger than -2. And there's a point there, which means it can equal -2. So I'm going to say x is greater than or equal to -2. Or the other way, if you prefer an algebraic way, don't forget you can set everything inside the square root to be greater than or equal to 0 and solve for x. So again, I don't care which way you do it. You only have to do it one way, so you pick which way makes most sense to you. Okay, and then when I solve for x, I'm going to move this 2 over. So I'm going to subtract 2 on both sides. 2 minus 2 cancels and turns to 0. 0 minus 2 is -2. So we get x is greater than or equal to -2. All right, now the range, these are the y values. So you ask yourself, how low does the graph go? Oh no, that's the wrong point. Sorry. Ah! Sorry guys, the demon cats keep getting me. Ah! Okay, so, whoa, now I'm dropping markers. Okay, so you ask yourself how low does the graph go, which if you see the graph is going to steadily head downward, so it's going to head in a negative infinity direction. It's going to keep heading down. Okay, and be careful, you guys. The demon cats hang out at negative infinity, so watch yourself. Okay, so it's going to head down for forever. And then you say, well, how high does the graph go? Well, the highest y value on the graph is -2. That's how high it will go. Okay, so are these numbers right here larger or smaller than -2? Well, there are things like -3, -4, -5. So these are values that are smaller than -2 or less than -2. So for the range, we'll say y is less than or equal to -2. Again, it can equal -2 because there's a point there. All right, or the other way, since the graph is decreasing, this is when you say y is less than or equal to, here's our shortcuts. Okay, when it's increasing, its y is greater than or equal to k. When it's decreasing, its y is less than or equal to k. Well, this graph is headed downward, so it's decreasing. Okay, so since it's decreasing, we know its y is less than or equal to our k value, which our k value is -2. All right, so again, you can do it either way. It doesn't matter which way you do it. Okay, so whatever makes sense to you, that's what you need to do. All right, and again, so you can think about this. This is when it's increasing that you use less than or equal to. Another way you can say this, you guys, instead of increasing, you can say when a is greater than or equal to 0. Because when a is greater than or equal to 0, just like with quadratics, it will be increasing. Okay? All right, and then when a is less than or equal to 0, when it's negative, that's when it flips upside down. So if you don't like the increase or decrease, another way to look at this is when a is larger than 0, which in this one it was, that's when you use greater than or equal to. When a is less than or equal to 0, like in this one, it's negative, that's when you use less than or equal to. So whatever makes sense to you. Again, you guys did a wonderful job like normal. Nice job, you guys. Toodaloo.